The example which I'm showing you today is on the basis of vanilla RNN. Right. So let's start, and we are doing it with using Keras. So let's import all the necessary modules, and in second line you'll see I'm importing Reuters from keras.dataset. Means the dataset which we are using for this example is a Reuters dataset, and that dataset is already present in keras.dataset. Right. So in next line I'm dividing this Reuters dataset in xtrain ytrain and in xtest ytest equals to reuters.load data. Load data simply means it will download the data. And in the parenthesis, I have mentioned few parameters. Test split, we know test split simply means 20% of data I want to use for testing purpose and rest 80% data I want to use for training the algorithm. Now what is this num word is equal to none? See, we can write over here. Let's suppose if I'm writing 100 over here. Let's take the example. That simply means I want 100 most frequent words from the dataset. Means this 100 simply means I want 100 most frequent words in the dataset. But in our case, I don't want only 100 word. I want to work on the vocabulary of whole, means I want to use all the words which are present in dataset. So that's why I've written none over here. Right. Now let's see a demo of the dataset. Let me explain you about the dataset first of all, like what this Reuters dataset is exactly. So in this Reuters dataset, we have vocabulary size in training set of 35,247. This simply means in training dataset only, we have 35,247 different words, right? And these are the classes. See, this is just a demo, so I'm just showing you a very few classes. Otherwise, in this dataset, there are lots of classes, right? So for just showing you a demo, I've shown you these many classes. So the class is earn. First of all, let's see this example. Earn class. That simply means 2877 words, 2877 sentences, sorry, are present in train which belongs to earn class, and 1087 sentences present in test which belongs to earn class, right? In the same way you can see this example also. Crude class means 389 sentences are present in train which belongs to crude class, and 189 sentences are present in test which belongs to crude class, right? So basically this dataset is a text classification dataset, means on the basis of sentences we can classify that particular sentence belong to which particular class, right? Let's move forward. Let's see like how many different records are present in X train and X test, Y train and Y test. So I'm printing the shape of X train over here, and I'm printing the shape of X test. So what we get to know is there are 8982 sentences, samples or sequences present in X train, and there are 2246 samples present in X test. In the same way, I'm printing Y train and Y test. So these are the records present in Y train and Y test. Now let's suppose I want to see the data which is present in X-train. I'm saying like there are different 8982 sentences in X-train, right? So let's see the sentences, like what kind of sentences we are having in X-train or X-test, right? So print X-train 0. That simply means I want to print the sentence of X-train which is at 0th index, and I want to print the Y train which is at 0th location. So this is the sentence which is present at 0th location, right? So this sentence is basically a sequence. So these different numeric number means different words, and why these alphabets or words are in this numeric form, because our algorithm only understand numbers. And why we are getting number over here, because this is a this data set is already available, and some of the work already has been done on this data set, so that's why we are getting in this way. Otherwise, if we want to work on our own data set, then we need to perform, we need to do this task ourselves only, right? So we'll do that later, but for today's class just understand the concept. So this is the data which is present in X string, and this is a sequence. Sequence simply means sentence, right? And this is the corresponding Y value. Why we are getting 3 over here? Again, our algorithm understands only numeric things, and this is what we have done over here, label encoding, and after label encoding, this is the class, right? So this is the data in this form. So, okay, one more thing over here. Let's suppose what this 8 means. 8 simply means 8 is the 8th most frequent word in the sentence. And 10 means 10 is the 10th most frequent word. And 447 means it is the 447th most frequent word in the sentence. And okay, why we are getting this so big values over here? Because that simply means in the starting we have mentioned here none word. I just explained you, like none simply means we want to use all the words from the data set. We don't want to limit the data set, we want to use all the data set. So we are using all the data set, that's why we are getting so big values also. So that simply means 27595 means this is the 27,595th most frequent word in the sentence in the data set. Okay, so fine. Let's explore this example more. So now let's suppose I want to know like what this 8 index is containing, means this 8 is storing which particular word. I want to see this thing. So for that what you can do, I'm using one variable with the name of word index. Variable can be anything. Okay, I'm using here word index equals to Reuters dot get underscore word underscore index. Reuters, this Reuters which we have imported over here. Reuters. From this Reuter, I'm using this method get word index, means Reuter have get word index method by which we get index of all the words which are present in Reuter's dataset. And I'm writing here word index, this variable, and then floor. This is the random word I've chosen myself only. Word index floor means I want to see the index for this value, means I want to see the numeric value for this particular word. So let's comment this and see. So you'll get the output as 3025. That means floor is the 3025th most frequent word in this Reuter data set. And if I comment this, and let's see with the next word oil. So this shows us 62 means oil is the 62 most frequent word in Reuter dataset, right? Now let's suppose we want to perform the opposite, means we want to write here index and we want the corresponding word for it. Over here we want to write the index and we want corresponding a word for it. So how to do that? For that, we will perform this functionality. So what we are doing over here is I have created a blank dictionary. Dictionary means curly braces simply means we are creating a dictionary, and dictionary stores data in the form of key and value pair. All right. So that's why I'm using a loop over here for, and why I'm using two variables over here, key and value, because we want to store the data in a dictionary, and dictionary whenever you want to store the data, that data should be in the form of key and value only. So that's why we using two variable to store. One variable will store the key and other variable will store the value in word index. Okay, what is word index? Word index is this, where we have get all the indexes from Reuters dataset. And I'm using dot items over here. Means what we are doing over here is from Reuters datasets, we are getting all the items and we are storing all the items in the form of key value pair, and we store those items, and we want to store those items in the dictionary, which is a blank dictionary which we have just created. Index to word value equals to key, means when somebody write index to word and write value over here, means index over here, then we will get the corresponding key value. For example, over here, index to word, this variable, index to word, and we need to give key over here. So let's suppose I've written 62. I want to see 62 index have given to which particular word. So I've written 62 over here. So it gives us the corresponding word over here, right? So in these two examples, we are working on only single word. But what if I want to see, like in this whole sentence, in this sequence, instead of these numbers, I want to see the actual sentence, actual words over here. Then how to do that? So for that, we need to do like this. Print join. Why I'm using join over here? Because we have multiple words in a sentence and we want to join all those words, then only we can get the output in a single sentence. Join index to word, this index to word. X, for X in X train 0 location means from X train the data which is present at 0 location. Which data is present at 0 location? This data, this line is present at 0th location. The line which is present at this location, I want to perform index to word on it, right? And then when you print it, you'll get the actual sentence over here. So this is the sentence which is at 0th location of X train, but it was encoded as a number. But using one method, we can see the actual sentence of it. In the same way, let's suppose you want to see another example. I want to see the seventh record. I want to see the seventh record of X train. The same way, use that index to word over here and you can see the seventh sentence. Clear? So this is just the basic of this data set. We have just explored about the data set. Now, the next thing is what we are doing over here is I'm importing tokenizer from keras.processing.text. From keras.processing.text, I'm importing tokenizer. Tokenizer simply means dividing the sentence into a tokens. And over here, I'm writing max words is equal to 100. So now while building a algorithm, I don't want to use all the words from the data set. I want to use the limited word. Means I want to use over here the 100 most frequent words. In the starting, I have mentioned none. Means I want to use all the words. But now what I'm saying is I don't want to use all the words, but I want to use only the top 100 most frequent words, right? So I've created one variable tokenizer, and in this tokenizer variable, I've called this tokenizer and num words is equal to 100 max word. That simply means we want top most 100 frequent words. All right. So now we have a data in xtrain and xtest. We have a data in the form of sequence, like this is a sequence means sentence. So now we need to convert this data which is in sequence into the matrix, right? Whenever we want to work on RNN problem, then always remember we need to convert the sequences to matrix. So that's what we are using over here. Tokenizer have a method sequence to matrix. So we are calling that method and we are performing this sequence to matrix on xtrain and xtest one by one. Mode binary means we want a matrix, but that matrix should be in the form of zeros and ones only. All right. After converting the sequence into a matrix, let's see the shape of xtrain and xtest. Okay. The shape of xtrain is now 8982 sentences and 100 words in each sentence. Alright. Why 100? Because we have mentioned here number is equal to 100. That's why we got this. In the same way, this is the shape of xtest means 2246 sentences and 100 words in each sentence. So this is what happened when we perform this sequence to a matrix. Now we have xtrain and xtest, and xtrain and xtest have equal number of columns equal number of features, which is 100. Okay. So next, now the next thing is we have performed the functionality on input data. Now let's talk about output, means Y train and Y test. So I have told you in the very starting classes of deep learning, like in deep learning, whenever we want to work on Y, so we need to do one hot encoding on Y. So that is what we are doing here. So keras.util, we are importing two categorial. With the help of two categorial, we can convert our data into one hot encoding. So we want to perform one hot encoding on Y train and Y test. Num classes means how many number of, we want to convert the Y train data into how many different columns. And how to decide we need how many different columns? It depends upon the number of classes we have. So in Reuters dataset, we have 46 classes, right? So that's why, and 46 have stored in num classes. So that's why I've written here 46. So after performing one hot encoding, let's check the shape. Ytron.shape is 8982 records sentences, and for every sentence we have 46 columns, right? Okay. After that, okay, now is a time to build a network. Now we will build a simple RNN. Till now we have just performed the pre-processing. We have viewed the data, we explored the data, and then we did some pre-processing on data. Now is the time to build a model. So whenever we want to use RNN, so always remember RNN accept input in the form of 3 dimensions. RNN will accept the input in 3 dimensions. What are those 3 dimensions? So these are the 3 dimensions: samples, time steps, and features. Sample simply means one sequence, means one sample. And sequence, I've already told you, sequence means sentence. One sentence means one sample. Means whenever you want to use RNN, you have to give these 3 parameters to RNN. Let's see with the help of coding only. So these are the important modules which we have imported, right? Okay, and I've told you like RNN will accept the input on 3 dimensional way, right? So before that, before dividing our data, before converting our input into a 3 dimensional, this is the step which we have performed. What I'm doing over here is, see, xtrain and xtest, and I'm using pad sequence. Let's understand pad sequence first of all. So pad sequence is, suppose this, see over here I'm just explaining you what is pad sequence. So pad sequence is, suppose I have a variable with the name of x, and in this x variable I have multiple lists. One list have 2 elements, other list have 3 elements, and then the next list have 1 element, and then the next list have 4 elements. Alright. So if you see it properly, so every list have different number of elements, right? And pad sequence, why we are studying about this pad sequence? Because in case of variable length sequence problem, this is a variable length. Variable length means every list have different number of elements, right? So this is a variable length. So when we have this variable length problem, it is always important that your data should be transformed such that each sequence has the same length. Means in RNN, if you want to perform the functionality, every sentence, every sequence, sentence means sequence, every sentence should have equal length. Means every sentence should have equal number of words. But it is not possible to have equal number of words in every line, right? Every sentence. So what we can do is we can use pad sequence. Pad sequence simply means we can fill the missing space with the zeros so that the length of every sentence become same. Is that clear? We are using pad sequence. Why we are using pad sequence? Because we want that every sentence, every sequence of the data set should have equal number of words, but it is not possible to have equal number of words. Then that's why we are putting zeros so that the length become equal. So that is what we are doing over here. Pad sequence. So pad sequence already have a module. We are just importing it and using it. Pad sequence, pad xtrain and xtest. Padding is equal to post means fill the missing spaces with zeros. So now we have padded our data. Now every sentence have equal length. Now this is the time to convert our xtrain and xtest into three-dimensional data. Three means sample, time step and feature. Xtrain numpy.array xtrain. How many total samples are there? We will get it from xtrain. And then we are reshaping our data and we are writing xtrain.shape0. Shape0 means how many total number of rows are there. Time step means how many rows are there. Shape1 means how many columns are there. Features means how many columns are there. So by writing this line, we are converting our data into a three-dimensional. Sample means how many records are there. Time step means how many rows are there. Feature means how many columns are there. And we are updating our xtrain and xtest variable. Now we have our data in the form of three-dimensional input. Now we can pass this values, we can pass this input to our algorithm. Now I'm creating an algorithm. I've created a function with the name of vanilla RNN. You can create it with any name, right? So in this, I've created a model. So I've created a very small model because this is just a beginning. In our further classes, I'll explain you in detail also. So which model I've created? Sequential model. And in this sequential model is a variable in which I've called this sequential. Now we want to add layers in this model. To model.add, which layer we want to add? Simple RNN, right? In the starting of this class, I've told you like today we are going to implement a simple RNN model. So that's why I've imported a layer simple RNN in the beginning and I'm calling that layer. I want to add this simple RNN layer in a model and 50 means 50 neurons. Input shape. So we always need to give shape of our data over here, right? Max word. So max word we have above. Max word means 100 most frequent words, right? So we are telling our algorithm over here, our RNN model over here, that number of features are 100. Return sequence false. We will discuss this topic in our next class in more detail. But today, just know this thing only. So this is a very simple model. I'm using only one RNN layer over here. If you'll see one RNN layer, then I'm using dense layer directly. So that's why this return sequence is false. So when we have multiple RNN layer, then we make it return sequence true. We'll discuss more about this in next class. Okay. So return sequence false. This is the RNN layer and then dense layer. Dense layer means fully connected layer. And over here I'm writing num classes means this is our output class, and in deep learning we know like final layer will have how many neurons? Means it depends upon the number of classes we have. So how many total number of classes we have? 46. Right? So dense num classes, and then the which activation function I want to use over here? Softmax. Softmax is a function which will calculate the probability. So we have lots of classes in it. So means on the basis of sentence, it will tell us which particular sentence which belongs to which particular class. And model.summary to check the summary. This is the summary of our model. And then I'm using optimizer. What an optimizer does is on the basis of error, it will update the weight, right? And then I'm compiling a model by using model.compile. And metrics, what we want to see is we want to see accuracy, right? And then return model. Now we have created a model. Now we will call the model. We'll use the model. So for that, this is the required module which we are importing. We need Keras classifier. I'm updating this variable only, model equals to this Keras classifier, and then in parentheses I'm writing build fn. Fn means function. Which build function? Which function we have created? We need to write the name of that function. What is the function name? Vanilla RNN. So vanilla RNN, which build function vanilla RNN. How many epochs we want? 5 epochs, and batch size is 50. And then I'm fitting X train and Y train in model. Means this is the training process. How many epochs will run? 5 epochs. So let's see the output. After 5 epochs, this is the accuracy which we are getting. See, accuracy is very less right now because I have run a very few epochs, just so that I'll get examples soon. So you can increase the number of epochs and then check the accuracy again. So means on our training data set, our algorithm is giving us 48% accuracy. Now let's test our algorithm. Over here, you'll see while testing means we use dot predict method on X test and then check the accuracy. So this is the accuracy, 49% accuracy on a test data set. So this is the basic RNN code. So thank you for now.